Hello everyone, I welcome you all on my channel. Today we will see the exercise 7.3 of class 9. Chapter name is triangles. So question number 1 is, this is the figure for the question number 1. It says AB is equals to AC. We are given with AB is equals to AC. AB is equals to AC and further DB is equals to DC. This DB is equals to DC. So these two things are given to us. Number 1, we have to show that triangle ABD is congruent to triangle ACD. Number 1, we have to show this thing. Let's draw these two triangles. This is my point A, B, D, and second triangle is A. So this is my A, this is D, this is point C. This point is C here. So we have to show these two triangles congruent, in which we are having AB is equals to AC and what else, DB is equals to DC, as shown in above figure. So we can write to prove number 1. We will write it like in triangle ABD and triangle ACD. We have AB is equals to AC and this DB is equals to DC. Both are given to us in the question and these are S. This is about side. Side is equals to side. Side is equals to another side of second triangle. So what else we have? AD is equals to AD. We can see that this is the common side. This is the common side. So this is also side. So side by SSS criteria. This is the third number criteria according to the book of grade 9. SSS criteria. We have shown that triangle ABD, this triangle is congruent to triangle ACD. So this is the criteria: when three sides of a triangle are equal to the three sides of the second triangle, then both the triangles are congruent to each other. So this was given to us, in the question. AD is common. So by SSS criteria, these two triangles are congruent. Let's see the second part that we have to prove. So in the second part, we have to prove that triangle ABP, which is triangle ABP, this triangle ABP is congruent to ACP. Let me draw the triangles first. This is my P, this is B. So this triangle I have to show congruent to A, P, and I will take my C here. Fine. So what is given in the question? This side is equals to this side is given to us. Rest we will check what we can prove equal and then congruent. Let's see. We will write it like in triangle ABP and triangle ACP. What we have? AB is equals to AC. That is given to us. So this is about the side. Write it like this. Next, AP, we can see that AP and AP is a common side in both the triangles. AP is common. So this is again a side. Now we can see that we have proved in the first part that this triangle is congruent to this triangle, and we have just taken this side as in extended form till point P in the second part. AD is extending to point P, so D is somewhere here, somewhere here. So this side is equals to basically this side we are taking for these two triangles. So from here we have proved that these two triangles congruent in the first part. So by CPCT we can write that this angle BAD, this angle is equals to CAD by CPCT. Why? Because these two triangles we have just proved congruent to each other. So when these two angles are equal by CPCT, we can extend the name as P. This angle is what equals to, these two angles are same, just the naming we are changing because of the extension of this point D till P. So angle BAP is equals to angle CAP. We can write angle BAP is equals to angle CAP. How? From number 1, from part 1 by CPCT. Fine. So from part 1 by CPCT we are having these two angles equal, or in bracket to elaborate more we can write angle BAD by CPCT. What we were having angle CAD, just the name has changed till point P here. Rest is all okay. So this is what, this is an angle. So this is, we are talking about an angle. So this side and angle here, between these two sides we have taken side, angle, side. So here we will write therefore by side, angle is what is included here. By this rule we have shown that these two triangles named as ABP is congruent to triangle ACP. So second part we have proved. Hope you understood this well. Let's move to the next part. Part number 3rd, where we have to show AP bisects angle A and angle D. In number 3rd, AP bisects angle A and angle D. This is my AP. This is, see in the original figure, this is my AP. I have to show that AP is bisecting angle A, means this part we have to show is equals to this part, means this measurement we have to show this measurement, and angle D also. So let's talk about first about these two angles which we have to show. This means, basically this means AB bisects angle A means we have to show angle BAP. BAP is equals to angle CAP. This angle is equals to this angle. Fine. So when these two angles will be equal, this means AP is bisecting this complete angle A into two equal parts. Bisecting means basically two equal parts. Fine. So in the last part we have written angle BAP is equals to angle CAP from where? Part number 1 that we have proved by the CPCT of when these two triangles are equal. From their CPCT we are having, this was the part number 1, we were having these two angles equal. So just the name has changed, nothing else. So here we can write clearly, we have, or we can write from number 1 clearly, from part 1 we have, what do we have? These two angles equal. How? Because two triangles are congruent, and by CPCT we are having these two angles. Just this D can be written as P because D is extended to point P. So just write this, and we have proved the first, AP is bisecting angle A till here. This means therefore AP bisects angle A. Proved here. Next is we have to show that AP is also bisecting angle D. Let's talk about that. This means we have to show AP, this AP bisecting angle A, means angle D, sorry, means we have to show angle BDP. To show BDP is equals to angle CDP. This thing we have to show, and to show that these two angles are equal, we don't have much in our hands, so we will just prove, first we will prove that this triangle is congruent to this triangle. This thing we can prove. So let me draw the triangles for you. This is my triangle DBP, and the second triangle is, this is again D, this is my P, this will be automatically C. So what we are given with? We are given with this side is equals to this side. Fine. So we will first show. So here we can write dB is equals to DC. This is given to us. This is a side. Fine. dP we can see. dP is what? Common side. So this is also a side. What else we are left with? So with what we can prove, these two triangles congruent. So I can see here that in the second part I have proved that this triangle is congruent to this triangle. These were the figures. So by CPCT I can write that BP is equals to CP. By the CPCT of the congruency of these two triangles, I can directly write BP is equals to CP. So here I have BP and CP. So I can write BP is equals to CP from part number 2 by CPCT. Fine. This much reason is accurate to write here. So BP is equals to CP. This is again a side. So by SSS, by side criteria of congruence, what we are having, triangle DBP, write the same names that you are taking, DCP. Now we have proved that these two triangles are congruent by SSS, but we have to prove that actually we have to prove that angle BDP is congruent to CDP. This angle BDP is congruent to CDP. Here I can see BDP. This angle is equals to CDP. This angle. So when these two triangles are congruent, directly I can write by, therefore by CPCT, angle angle BDP. I am repeating again, take the same names for the angles and triangles once you have taken in the question. Throughout use that names. So BDP is equals to CDP, which means AP is bisecting angle D. So here you can write in the end, therefore AP is bisecting angle D. So we have done with part number 3rd. Let's move to the part number 4th. What we have to prove in it. Let's see. It's saying AP is perpendicular bisector of BC. AP is perpendicular bisector of BC. Basically, to show AP is perpendicular bisector of BC means perpendicular as well as bisector. Means we have to show BP is equals to CP as well as perpendicular. Perpendicular means this angle APB is equals to angle APC is equals to 90 degree each. Two things we have to prove. In the last part we have shown that, or direct from the part number 2, we have shown that by CPCT BP is equals to CP. So we have done with this part. Let's see how to prove this part. APB and angle these two angles. No doubt these two angles are equal. From where part number 2 by CPCT we can also write angle APB and angle APC equal. But we have to show 90 each. So let me show it for you. I will write it like. So this is basically a line. BC is a line. This is acting as a ray, AP. Fine. BC is a line. AP is a ray. Therefore, angle APB plus angle APC is equals to 180 degree. How? Linear sum of angles or linear pair of angles. Fine, linear pair, right? Linear pair of angles. So APB plus APC is equals to 180 degree. This complete angle is what? Of 180 degree. But I just told you from part number 2, by the congruency of these two triangles, what I have, we will write from number 2, angle APB is equals to angle APC by CPCT. So these two angles are equal. So I can write this APB as APC. I can put the value of APB as APC in above equation. So APC plus APC is equals to 180 degree. 2 times angle APC is equals to 180 degree. So angle APC, I will take this 2 in the denominator on the right hand side. I will left with 90 degree. So APC is now APC is what? 90 degree. So these two angles are equal. So APB will be of 90 degrees. So we have reached to the result. So all the 4 parts I have explained in a proper way. Hope you get all the points, each and every point of this question. So let's move to the question number 2. So this is the question number 2. Here statement is given to us without figure. So we will create the figure by ourselves. AD is an altitude of an isosceles triangle ABC. So we will just draw a triangle that looks like an isosceles triangle. A name is what? ABC. So this is an isosceles triangle with AB is equals to AC. This is given to us. We have to show that AD is an altitude. AD is an altitude. Altitude means this AD line is making angle of 90 degree on BC. So we have to show that AD bisects BC. AD is bisecting BC means this BD is equals to CD we have to show, and AD bisects angle A means angle BAD is equals to angle CAD we have to show. Let's move with the part number 1. So let's write what we have in the question. This is the solution or proof. So given AB is equals to AC, fine, and what else we have? This is an altitude. AD is an altitude means angle ADB is equals to angle ADC is equals to 90. Each is already given to us because AD is an altitude. So number 1, we have to show AD bisects BC means AD bisects BC. AD bisects BC means this BD is equals to CD. So we have to show BD is equals to CD. So let's try to prove these two triangles congruent. So I will write in triangle. So these are basically 90 degrees. So I will draw it like right angle triangle. This triangle ABD and triangle what else? ACD. ACD. So first is AB is equals to AC is equals to, this is given, and about, we are talking about the side here. So AB is equals to AC is given to us. Next is what? These two angles are equal because of 90 degree. So I will write ADB is equals to ADC is equals to 90 each. This is also given to me. This is a right angle. Fine. So right now denote it as capital R. Rest in these two triangles, in this triangle and in this triangle, I have AD common. AD is equals to AD is what? You can see it's a common side. So this is common. This is again a side. So from here, what is we can say that if this is a right angle triangle, here angle is 90 degree, and in opposite to this angle, the AB is what? Hypotenuse. Similarly, in this triangle, AC is what? Hypotenuse. So this side is basically hypotenuse. Then by, this is a criteria, RHS criteria, right angle, hypotenuse and side, any side. Rest from the two other sides. This is hypotenuse, this is right angle, this is side. This is also a criteria to prove the triangles congruent when two triangles are right angle triangles. So for such triangles, this is a criteria. So by this criteria, where two right angles, two hypotenuse of both the sides, and any of the sides that we are left with. So AD is common. So by RHS criteria of congruency or congruence, we have these two triangles congruent. ABD is congruent to ACD. Fine. So when these two triangles are congruent, we can directly write by CPCT that BD is equals to CD. So here I can write, I am writing here by CPCT, BD is equals to, this BD is equals to CD. Hence proof. So first part we have done with. Let's see the part number 2. In part number 2, I have to show AD is bisecting angle. This AD is bisecting angle A means this BAD is equals to CAD. I have to show angle BAD is equals to angle CAD. So I will not write it for you. I am just explaining. We have just proved that this triangle is congruent to this triangle by RHS congruence criteria. So these two triangles are congruent. Now when these two triangles are congruent by CPCT, what I am having or what I can have is this angle is equals to this angle. This is the thing they are asking us. So by CPCT, directly you can write by CPCT. From number 1 we have proved that this triangle is congruent to this triangle. Now by CPCT, angle BAD is equals to angle CAD, hence proved. So these were first two questions of exercise 7.3. Rest of the questions we will discuss in the next video. Hope you like the video. Hit like and subscribe for more, and please share it with your friends and mates. Thank you for watching.